Okay. So this is functional notation. F is the name of this function, and G is the name of the function that is being transformed. G is the name of the function being transformed. So A is the multiplier, or remember, if A is greater than 1, it was stretching. If A is less than 1 but bigger than 0, it was shrinking or compressing. But that's just the multiplier, right? If it's a multiplier of 2, you multiply the y values by 2, that sort of thing. The inside, that H is the horizontal shift. Remember, you went right or left. And the K is a vertical shift. You went up or down. So this is all in one expression, right? If A is negative, it's reflect across the x-axis. If A is negative, it's reflect across the x-axis. You want me to read it to you?
Yeah.
All right. So A is the multiplier. So you remember, if it was bigger than 1, you stretched it. If it was less than 1, you shrunk it. Oh, we also said it's dilation. And by the way, it's D-I-L-A-T-I-O-N, not D-I-A-L, blah, 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 blah. It's dilation, not dilation. You've been giving me a lot of lip lately, Bailey. Did you develop a personality? No? What was that? Hey, don't forget we're being recorded.
That didn't stop you. Oh my god.
Give us a warning.
I did.
Yeah. Now we can play back the video and hear your hiccup.
That was Gabby's hiccup.
No,
that's coming.
I'm scared of the one.
All right, moving on.
I think you're gone now.
Okay, so here's you hiccup like a chicken. Is that what you said?
Her hiccup sounded like a chicken.
I don't think you ever heard a chicken. That does not what a chicken sounds like. Okay, sorry, moving on. 2A. Okay, so this is the inside, right? This is the inside. So this is what the function looks like. X is the function, and it's x minus 5. So that is right 5. That's all I'm asking you to do. Just write 5. Right, so this is a transformation of right 5. If you want to write horizontal shift right 5, that's correct too. But
How do you know that?
because it's minus 5. Remember this thing here? This is the idea, the minus 5. So it's horizontal shift right 5.
Why not left or down or up?
If it's plus, it will be left. And if it's outside the parentheses, it'll be up or down. Well, technically, you could argue this is down 5, but we're not going there. I personally think this is not a good example. We'll get to better ones in a minute. All right, H. Oh, I'm sorry, B. I thought that was an H. Okay, so what is this one? This is going to be right 4, up 1. Right 4, up 1. But you could argue it's down 3. But don't go there.
What?
Okay, I'll shut up. I'll quit trying to make you confused. I just don't like these things. I think I should have spoke up before I printed it. Alright, ready for C? C. C. Okay, so there's a negative sign up front. That's the reflect. Reflect across the x-axis. And then the plus 1 is what? Left 1. D? D. Okay, so this is a good example. So this is a typical function. See, I have a function with an exponent of 2. So look over here, the exponent of 2 is outside of x plus 2. So this is more obviously, this is outside, right? The 2 is outside. So that makes the plus 4 inside the parentheses. So it's inside, so it is what direction?
Right.
It's sideways, so it's left. Remember, it's the opposite of what you think for the inside, so this is left 4. Alright. Let's look at E. Okay, good question. His question is, do we do anything with the square? No. The function does not matter. Transformation rules apply to all functions. The function itself does not matter. So if the exponent of 2 does not change the way you answer the question. Okay? So like some of you think, well, absolute value makes it positive. It doesn't matter. You just do the transformation the way you do the transformation. What are you doing? What is that in your mouth? Oh, okay. Alright, so look at this example. Look at E. So which direction is this going to go? Right. Right, how many? 3. Right, 3. Right? Okay, F is goofy. We'll do it anyway. So you have a 2 on the outside, so that is a stretch by a factor of 2. Do you remember the other way to write that?
Dilated.
Dilated by a factor of 2. Right? So the other way is dilated by a factor of 2. You don't have to have both, you just have to have one. And what's that negative sign do inside? It's reflect across which axis? The y-axis. And then you could argue, no it doesn't, Mrs. Schweitzer.
I'll mark there.
What happens when you reflect the absolute value across the y-axis? Do you remember what the absolute value looks like? Absolute value looks like this. What happens if you reflect that across the y-axis?
Oh, nothing.
Nothing. So you could argue, that doesn't do anything. So which makes for a lousy example.
Can I see E real quick?
Can you who?
E.
E. Alright. E was right 3.
Thank you.
Alright, G. So this one's good. This is a good example. So the negative sign outside makes it a reflection across which axis? Y-axis.
Wait. Why? Wouldn't it be X? Because last time it was on the inside?
Yeah, you're right, it's X.
That's a new letter you just made there, I think.
No, that's a mistake.
Yeah, I know, but it looks
You don't need to save me embarrassment. I'm used to it. I do. My favorite letter is this one.
What is that?
A B?
That's an estet.
Oh, what? What is that? Say that again.
Estet.
It's,
German.
what is that?
It's a German letter.
Before Y.
For what?
B.
B?
No, it's an S, isn't it? Isn't it an S? Yeah, it's an S. Alright.
S. He doesn't even know what it is.
Oh my god, and it's his favorite.
He just likes the way it looks.
Yeah, no, it's a cool looking letter.
That's not
It writes cool too. I mean, that's a cool. It almost looks like a bird.
German. It's German.
Anyways, I'm not done with G. I'm not done with G.
Wait, draw it again.
So, which direction does that -1 take it?
Right.
Right. That was Gabby's fault. We got this letter kick.
That's what he said. Is that a bird?
Oh my gosh, yes.
No, I'm not. Oh my gosh. I like knowing
I think we get weirder when we record.
Hey, you guys at home are getting some entertainment.
What's your favorite letter in English?
They're all boring.
Letter Z.
That looks like a 7.
It looks like a.
That ain't a letter.
That's a T.
That's a Z. This is a T.
That's a T with a little pizzazz.
That's a T. Or a T. Okay, moving on. We only have, well, there's more than one example left, but. Alright. H. Okay, so what is this? So we have a half in the front. That makes a shrink, right? Compression. By half.
Compression.
Sometimes they write compression by 2. Can you guess why? Instead of half, they write compression by 2.
What is it?
Because the compression does the fraction part. Alright, and is the plus 3 left, right, up, or down?
Right.
Up. Up 3.
What's the number beside compression by?
Half. It's that number in the front.
You didn't tell us.
Right there. Number in the front. Oh, I see what you're saying. It's getting stuck on the thing.
What's your favorite superhero, Mr. Fonzie?
You like soup?
Go talk to him.
Mr. Schweitzer, can you sign my paper?
Huh?
Marvel or DC?
Marvel.
Thank you.
I mean, I watch DC too, but
Can we get a second? Who's your favorite? Who's your favorite?
Black Widow. She kicks butt. Or Deadpool.
Okay, yeah, that was original.
He's funny. Alright. I'm going to do 2 problems from the homework. One from the front. You pick one. 3. I got a request for 3. Okay. Let's talk about all the problems at once for a minute. Okay? So this is the format. Okay, please stop making that noise. This is the format. T of x equals A. A is going to be replaced by a number. On the front page, A is going to be 1 or negative 1. On the front page, A is going to be 1 or negative 1. So I'm not giving you anything other than 1 or negative 1 in the front. Okay? H, remember H is the horizontal shift. This is the horizontal shift. And K is the vertical shift. Okay? So if A is positive, see this original function? The original function looks like this. If A is positive, it's going in that direction. Right? So positive 1, and if it's going downward, then guess what A is? Negative 1. Alright? So I'm going to do number 4 though, okay? I'm going to do number 4. Now, H and K is, H is the horizontal shift. In other words, here, the original function is centered at 0, 0. Right? So the best way to do it is check to see where the vertex moved to. So looking at number 4, the vertex moved from 0, 0 to 2, 0, 2.
Yep.
Is that out of focus?
There you go.
Hang on.
It's good now.
Yeah.
Alright. Okay, so let's write out the answer. So that'll be, so this is the transforming function. A is negative 1. And you go to x. Now, did I move left or right? No. So you can write minus 0 or you can just write x squared. Okay? I am writing this for emphasis. And then, did I go up or down? Up. How many units?
2.
2. So this is the answer to number 4. This is the answer to number 4. So the negative 1 reflects the fact that it's turning downwards. The minus 0 means it moves it didn't move sideways at all. and the plus 2 means it moved up 2. You had a question, Ethan?
Do we have to put the squared?
Yes, you have to put the squared.
What's that for?
That's the function you're dealing with, right?
When are we gonna use this?
The parent function is x squared, so that's why we have to have squared.
So technically, do we have to write the negative or positive ones? Because we just know it's
I
there.
agree with Tucker.
You mean you write negative instead of negative 1?
Yeah.
Yeah, that's fine. So, hey, if you want to get like technical, you can just have negative x squared plus 2. So this is a good answer for that one. Okay? But if you write it all out like that, that's okay. Abigail.
Where did the negative 1 come from again?
Okay, see how the parabolas turn this way,
Yes.
but the originals turn this way?
Yes.
So it's negative because it's turning the opposite direction.
So if it was turned up, it's a plus 1?
Positive 1, yeah.
And then we wouldn't have to put anything since we.
Correct.
Okay.
Alright? Ready for the next page?
Sure.
Next page. I'm doing one problem off the next page.
Wait, so what was that answer? X of 2 and plus 1?
This is the answer. You can have either one of these.
Oh, okay. Why is it negative? Or because it slopes down?
Yeah.
Oh, okay.
Okay.
You please spell it.
So on the front, A was limited to positive or negative 1. On the back, there is no limit on the A, other than it can't be 0. Okay, A can't be 0, but it could be just about anything else. Okay, so I'm going to do an example where A is not 1. Let's see, let's do number 9. We'll do number 9. Okay, so this is what the original function looks like, right? This is the absolute value function.
Starts at 0, 0.
Uh-huh. And where does 9 go? 9 goes to where?
Right. And then.
Right 4 and up 3. Okay. So then you're going to do a transform function. So I'm doing number 9 equals, now, the number in the front. We're going to figure out what the number in the front is. Here's what you do. You look at the vertex and do you guys know what a lattice point is?
Yeah.
No.
Lattice point are these points, right? These are lattice points.
Lettuce?
Lattice. L-A-T-T-I-C-E.
All of them.
Okay? So here, the line goes through this lattice point and this lattice point. So look at the slope. What's the slope of that line?
3.
3 or negative 3, right? So it's facing downwards, so it's got to be negative, and you just said it had a slope of 3, so it's negative 3. So the A in this example is negative 3
Because it goes down.
because it goes down. It's negative because it goes down. It's negative. It's 3 because you counted that slope of 3. And then X. Now I went 4 units to the right, so that's minus 4. And I went 3 units up, so it's plus 3. And that's the answer to number 9.
Can you write it the other way?
Why did you use absolute value?
It's absolute value because that's the function, absolute value.
So the slope goes in front of the absolute value.
That is correct.
Okay, that makes sense.
Okay, the slope is the A in this example. Yes, Abigail.
If the denominator on the slope was less than 1, would it just be a fraction outside of the?
Yes.
Can you write it in that other form?
What other form?
Like you did on number 4?
Well, this one, nothing simplifies, so that's it. Right, the 3 doesn't go away, the 4 doesn't go away, so this does not simplify anymore. Alright, now I'm going to give you class time to do it. These are pretty easy. The ones on the 3rd page are pretty easy, so you should be able to do that. Okay, I'm giving you class time to work on it. Most of the first period was finished before they left for the day.